Today I'm gonna talk about the derivative of composite function, the application of chain rules twice. Here I'm gonna focus on trig function and exponential function. Now let's take a look at the following formula. The first formula is a typical chain rule, and here the capital F can be any trig functions. For example, if capital F is a sine function, then the derivative of f should be cosine function. If capital F is a cosine function, then the derivative of capital F gonna be negative sine function. If capital F is tangent function, then the derivative of capital F gonna be secant square. Okay, and the second derivative is about the derivative of composite exponential function. The derivative of e to the power fx equals e to the power fx times the derivative of fx. The third one is power rule, and the derivative of x equals 1. And the fourth one is constant multiple rule. I also list the derivatives for 3 trig functions. Now let's take a look at the first example. Let's take a look. Here we have sine e to the power 2x. If we want to apply the chain rule, we can easily tell the capital F is sine, and the little fx here is e to the power 2x. So we can write down e to the power 2x. Now we can write down the derivative of sine, or derivative of capital F gonna be cosine. Okay, and fx e to the power 2x, and times derivative of fx. So we have e to the power 2x prime. Okay, and now let's focus on the second term. For the second term, we can easily tell that is a composite exponential function. We're gonna apply the formula 2. Okay, and here what is fx? The fx is 2x, so we can write down the fx equals 2x. Then we can apply this formula. Now we can copy the first term, and for the second term we're gonna follow this formula, e to the power fx, and times the derivative of fx, or derivative of 2x. Okay, we can continue copy the first two terms, and here 2x we can apply the constant multiple rule. So we can pull this constant 2 out of the derivative, and we do the derivative only on the x. Okay, and x prime equals 1, or derivative of x equals 1. So this guy will be 1. So that means 2 times 1 equals 2. And we can simplify it. That guy will be 2 cosine e to the power 2x times e to the power 2x. That's it. Now let's take a look at the second example. Now the first step, we're gonna figure out what is capital F. that is cosine, and what is little fx, that is e to the power 2 times sine x. Okay, so we have little fx equals e to the power 2 sine x. And basically we're gonna follow this formula. The derivative of capital F, that means derivative of cosine, means negative sine. Okay, and fx, that is e to the power 2 sine x. And do the derivative for the e to the power 2 sine x. Okay, and for the second term, we can tell that is the composite exponential function, and we know the letter fx is 2 sine x. So we have fx equals 2 sine x. Okay, now we can apply this formula for the second term. So we can copy the first term, and for the second term we follow the second formula, e to the power fx and times the derivative of fx, that is 2 sine x. Okay, and now we can tell for the third term, here is 2 times sine x. So it's very clearly we can apply the constant multiple rule. That means we can pull the 2 out of the derivative, and we do the derivative only for the sine x. Okay, so we copy the first term and times e to the power 2 sine x. And for this term, we're gonna be 2 times derivative of sine x, gonna be cosine x. Okay, now we can simplify it. Negative 2 cosine x and sine e to the power 2 sine x times e to the power 2 sine x. Okay, now let's take a look at the last example. For the last example, we're gonna follow the same strategy. The first step, we're gonna figure out what is capital F, that is tangent, and what is little fx, that is this guy, e to the power square root of x plus e to the power tangent x. Okay, now let's follow this formula. Tangent, derivative of tangent gonna be secant square. Okay, fx is e to the power x plus e to the power tangent x times derivative gonna be fx, that is here. Just copy it, and now we can simplify it. We're gonna copy the first term, and for the second term, we can see here's the derivative of the sum of two functions. That means we're gonna do the derivative for each function. So we have here, do the derivative for the first function. We're going to do the derivative for the second function. Okay, now let's take a look at these two functions. For the first function, we can tell what is fx if we apply this formula. We know that that fx equals square root of x. Okay, and for the second function, we know little fx equals tangent x if we compare these two. Okay, compare these two. Now we can apply the formula 2 for both terms. Okay, for both derivative. We're gonna copy the first term and then for the first term we're gonna follow the formula, do the derivative of e to the power square root of x, and then do the derivative of fx, that is square root of x. And for the second term, again, we have e to the power tangent x times derivative of fx. Okay, now here square root of x can be written as x to the power 1/2. Okay, it's clearly we can apply the power rule for this term. How about this guy? The derivative of tangent x is gonna be secant x squared. So now we can simplify these two terms. Secant square e to the power square root of x plus e to the power tangent x, and here e to the power square root of x, and derivative of x to the power 1/2. We're gonna apply the power rule. And again, for the second term, we're gonna do the derivative of tangent x, gonna be secant x squared. Okay, we can continue to simplify it. Secant square e to the power square root of x plus e to the power tangent x times, here is 1/2 minus 1 gonna be negative 1/2. So we have 1/2 x negative 1/2 times e to the power square root of x plus secant x squared times e to the power tangent x. That's it.